Today we'll be working on exponents, roots, and radicals, part 3. In parts 1 and 2, we talked about simplifying roots and radicals in exponents, and now we're going to take a look at solving equations with them. So say you have radical 10 over radical 18. How will we begin simplifying this? Well, we'd want to simplify our radicals as much as possible and then see what cancels out. So we can rewrite radical 10 as radical 2 times radical 5. And we can rewrite radical 18 as radical 2 times radical 9. Now we can see we have some factors in common, our radical 2's, so we can go ahead and just cross these out. Wonderful. Alright, so now we're left with radical 5 over radical 9. And radical 9, we know, is a perfect square, so simplifying that, we have radical 5 over 3. There we go. Say you had radical 36 over radical 12. You can also write this as one big radical with 36 being divided by 12. And from there, we just look for factors in common. 12 actually goes into 36 3 times, so we're just left with radical 3. Alright, let's take a look, see if we can solve radical 6 over radical 8. Radical 6 and radical 8 both have 2 in common, so let's go ahead and rewrite this as radical 2 times radical 3 over radical 2 times radical 4. So our common factor cancels out. We can go ahead and cross those out. So we're left with radical 3 over radical 4. Radical 4, we know, is a perfect square, so we can go ahead and simplify this as radical 3 over 2. Say you had radical 36 over radical 2. Well, radical 6 we know, or radical 36 is a perfect square of 6, so this simplifies down to 6. And then that's as far as we can go with this problem. However, you want to be careful to rationalize your denominator. What is this? Well, rationalize the denominator basically means you don't have any radicals left in your denominators. So we're going to rationalize the denominator with 6 square root 2 by multiplying by a clever 1. So we're going to end up multiplying by radical 2 over radical 2. Because what you do to the top of a fraction, you have to do to the bottom of the fraction, and vice versa. So what we're left with is 6 radical 2 over 2. Because radical 2 times 2 gives us just a 2 back out. And now our answer is simplified. Say you have the square root of 2 being raised to the second power. Since radicals and raising something to powers are inverses of each other, these operations undo each other and we're left with just 2 on the outside. Same thing if we had radical 6 raised to the second power, that would give us 6 back out. If we had 3 raised to the second power, raised to the second power and the square root end up canceling each other out, so we just have 3. You can do this with any number. Square root of 10 squared is equal to 10. Doesn't matter if it's being raised to the third power, if it's to the cube root. Say we have the cube root of 4 raised to the third power, we would get 4 back out. This is because inside the radical sign, there are secret exponents hiding out. So if we had 2, we had the square root of 2. Right here, there's a secret 1, and outside here, there's a secret 2. So if we were to rewrite this, we would see that 2 is actually being raised to the 1/2 power. And if we were to take 2 to the 1/2 power and square it, these functions would undo each other. Whenever we have a variable being raised to an exponent, being raised to another exponent, we can always see a times b in this case. So if we were to look at the 2, we'd see this as 2 1/2 times 2, which simplifies to just 2 to the first power. Same thing with anything raised to a higher power. So if we had, again, the cube root of 4 raised to the third power, what we're really seeing is the cube root of 4 to the first power. So we have 4 raised to the 1/3 power, and if we're going to raise the whole thing by 3 again, we have 4 to the 1/3 times 3, which simplifies back down to 4 to the first. So say you had something a little different. Say you had the cube root of 2 raised to the 6th power. Well, we could split this up into the cube root of 2 to the 3rd power times the cube root of 2 to the 3rd power, which would cancel out and just give us 2 times 2, which is of course 4.